Alright, so section 5.4, all about mid-segments of a triangle, which a mid-segment is a segment that connects the midpoints of two sides of a triangle. So it goes from one midpoint on one side to the midpoint on another side. And so just like everything else, we can have three of them in a triangle since we have three sides. But mid-segments, unlike all the other segments we've covered recently, will not be concurrent, right, which means that they're not going to all intersect at the same spot. So the mid-segment theorem tells us that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and half as long. So DE is going from the midpoint of AB to the midpoint of BC, making it a mid-segment. So this theorem tells us that DE, it's connected to these two sides, so it's parallel to the third side, AC down here. And it's also half the length of AC. So if we know whatever the length of AC is, then DE will be half of that length. Or if we know what DE is, then AC is going to be twice that length, depending on which way you look at it. So here it tells us to show that mid-segment PQ is parallel to DE and is half as long. So basically we're going to go through the process here to prove with math that that theorem is correct. So first thing, we can figure out if they're parallel. Right. In order for us to prove that they're parallel, what do we have to figure out? Anybody know? If two lines are parallel, what's got to be true about those two lines if they're parallel? They have to have the same slope. So what we'll want to do is figure out the slope of PQ and the slope of DE. And if indeed PQ is the mid-segment, then it should have, those two should have the same slope to be parallel. So slope formula, if we remember, is y2 minus y1 over x2 minus x1. So starting off, figuring out the slope of PQ, which I don't have those points labeled, but P is at the point 2, 3, Q is at the point 1, 2. So for our y's, it's going to be 3 minus 2 over our x's of 2 minus 1. Which is 1 over 1, or simply 1. So a slope of 1 for PQ. Then we want to do the same thing for DE. So for the y's, you've got a 2 and a 0, so 2 minus 0. And then 5 and 3 for the x's, so 5 minus 3. Which will give us 2 over 2, which reduces to 1. So since the slope of PQ equals the slope of DE, we can say that PQ is parallel to DE. Since their slopes are the same, we know they're parallel. So we can check off the first part of that problem, showing that they're parallel. Next thing we need to do is show that PQ is half as long as DE. So now we need to switch to a different formula. And we're going to use the distance formula to figure out the lengths of those two segments. So x2 minus x1 squared plus y2 minus y1 squared. So for PQ, start with our x's. We got 2 and 1, so 2 minus 1 squared. And then for the y's, be 3 minus 2 squared. So 2 minus 1 is going to be 1 squared plus 3 minus 2, which is 1 squared. And 1 squared is simply 1. So it's going to be the same thing as square root of 1 plus 1. So the length of PQ is going to be the square root of 2. It doesn't have a perfect square root, so just going to leave it there. Now I need to do the same thing for DE. So for DE, our x is 5 and 3, so 5 minus 3 squared. And then for the y's, 2 minus 0 squared. So 5 minus 3 is 2, so we got 2 squared. 2 minus 0 is 2 squared. So 2 squared is 4. That's going to be the square root of 4 plus 4. 4 plus 4 is going to give us d equals the square root of 8. Which 8 does not have a square root, but one of its factors does. Right? So 8 is the same thing as 4 times 2. So we could rewrite that as the square root of 4 times 2. And 4 has a square root, which is 2. So we can take the square root of 4 and pull it out. And we get 2 square roots of 2. Right? So we look at it, we've got the square root of 2 for PQ, 2 square roots of 2 for DE. So as you can see, PQ is half of DE, or DE is 2 times PQ. Questions on those? Alright, so this one, JK and KL are mid-segments of ABC. So find the length of JK and the length of AB. So this one should be fairly simple. Probably one of the simpler things we do today. So if they're mid-segments, then we know that they are half as long as the line that or the side of the triangle that they are parallel to. Right? So for JK, this one up here, it's parallel with the bottom side, right? So AC. So by the rule, we know JK should be equal to half of AC. And since we know what AC is, it'll be half of 10, or simply JK equals 5. And I'm not kidding about that either. All right, so then KL, being a mid-segment, should be parallel to BA and should be half as long as BA. And so we can set that up as saying that KL equals half of AB, which we don't know what AB this is this time. We know what KL is, so we can plug in the 6 for KL. Half of AB, which move the 1/2 over, we can divide by 1/2, which is the same as multiplying by its reciprocal. So over here we can multiply by 2. So AB is going to be 12. Pretty hard stuff. Probably could have done that in your head without setting them up, but alright, so then the next thing here, it's a little more complicated. I know what the coordinates of Q and of R are in this picture, which actually accidentally erased the marks on here because we need these so we know that Q and R are both midpoints of those two sides of that triangle. And so if they're midpoints, then we would need to use the midpoint formula to find the coordinates. The trick here on this one, though, is that if we look at the coordinates they gave us, they're not number coordinates, they're letter coordinates. But the math is still the same. All right, so this is just the midpoint formula. X1 plus X2 over 2, Y1 plus Y2 over 2. So for Q, the x's we're dealing with are a and 0. So a plus 0 over 2. And for the y's, it's b and 0. So b plus 0 divided by 2. Or the zeros can basically disappear. And that leaves us a over 2, b over 2. And then for R, same process again. So coordinates for the x's are a and c. So a minus c over 2. Or a plus c, sorry. And then for the y's, b plus 0 over 2. So the coordinates for R, the x one's not going to change, a plus c over 2, and then b plus 0 we can just call b over 2. Now, this next one is where it starts to get a little more complicated since we don't have real numbers here. It says y is line segment QR parallel to segment MP. Well, in order to figure out if they're actually parallel, we need to know the slopes of the two lines. So we use the slope formula. Start off with the slope of QR. So in order to find the slope, it's going to be y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. So for QR, we're looking at these coordinates right here, right? So a over 2, b over 2, and a plus c over 2, b over 2. So for our y's, we've got b over 2 minus b over 2 on top. And then for the x's at the bottom, it's a plus c over 2 minus a over 2, which b over 2 minus b over 2 is 0. A plus c over 2 minus a over 2, since they're both common denominators. A plus c minus a over 2, which technically would just be the a's canceling out. 0 over c over 2. It really doesn't matter because the top is 0. So 0 divided by anything is 0. And for the slope of MP, then we're going to have 0 minus 0 for the y's, and c minus 0, which will give us 0 over c, and anything 0 divided by anything is 0. So why are they parallel? Because they have the same slope. That wants to know the length of MP and the length of QR, which MP, we're just looking at the difference in the x's because those are horizontal lines. So MP is going to be c minus 0 or c. And QR, the difference in the x's is going to be a plus c over 2 minus a over 2, or a plus c minus a over 2, which those a's are going to cancel each other out. You get c over 2. So c and c over 2, so QR is half of MP. The midpoints of the sides of triangle are S 1,5, T at 3,3, and V at 4,6. What are the coordinates of the vertices of the triangle? So these are all midpoints. So we have to create the sides that are going to make the sides of the triangle, basically. So if I find the slope between 2 points, like these 2 points here, then if I use that slope on the other point, I can create a side of the triangle. So if I start with the slope of ST, which S is at 1,5 and T is at 3,3, makes this one V. So if I do ST using the slope formula, so 5 minus 3 over 1 minus 3, to give us 2 over -2. Or that reduces to -1 over 1. So using that slope, if I go to point V and I do a slope of -1, so from point V, I'm going to go down 1, that's the negative, going down, and to the right 1. So there's a point. I go down 1 and over 1, another one to make another point. Which then I can draw a line that goes through those points. And then I need the slope of SV. So for SV, we're going to have 6 minus 5 over 4 minus 1, or a slope of 1/3. So we're doing the slope of SV. So we're going to use that slope at point T. So from T, we're going to go up 1 and over 3, which will actually put us right here at this point that we already used. So that'll allow us to draw a line there. And then one more slope. A slope of, probably not done yet, VT. So it's going to be 6 minus 3 over 4 minus 3. Or slope of 3 over 1. So from S, we're going to go up 3, 1, 2, 3, and over 1. Put us right there. So draw that line in. And so now we can actually come up with the coordinates, right? For this one down here, we're at 0, 2. Over here, we're at 6, 4. And at the top, we are at 2, 8. All right. All right. So on to the last one here. It says that segment RS, segment ST, and segment RT are mid-segments in triangle XYZ. Find the perimeter of triangle XYZ. So these are all mid-segments, 5, 6, and 7. So we know that each mid-segment is half the length of the side that it's parallel to. Right? So basically, we look at side XZ. That side is equal to 2 times the length of RS. Right? That's mid-segment RS. Which 2 times RS, we know that RS is 5, so that's 2 times 5. That'll be 10 for XZ. For XY, we've got 2 times the length of the side that it is parallel to, which is TS. 2 times TS, and TS has a length of 7, so that's 2 times 7, or 14. And the third side, ZY, That's going to be 2 times the length of TR. And TR has a length of 6, so that's 2 times 6, or 12. So perimeter is just adding the 3 sides together, right? So if I add those 3, then my perimeter of triangle XYZ is 36 units. So that's one way you could do it. But another way you could have also done this, since the sides are related as a 1-to-2 ratio basically, then the perimeters are related in the same way. So I could have started off by saying the perimeter of triangle RST. I just added all the sides of RST, which would have been 6 plus 5 plus 7. Which is 18 units. And the perimeters, perimeter of triangle XYZ should have been equal to 2 times the perimeter of triangle RST. So if we knew that RST was 18, then take 2 times 18. And you get 36 units. So either way, you still get 36 units if you double all the sides and then add them together, or if you add all the sides of the mid segments together and then double those.